Very good afternoon, students.
Good
Good
afternoon,
afternoon.
sir.
Good afternoon.
So my audio, video, everything clear, right?
Yes. Yes, sir.
Yes, right. So let us start the discussion. Last class we have been studying about the chemical kinetics and zero order reaction, different examples we have been solving. So we'll continue with our discussion. So this was the last point of our example, last point of our discussion. We try to solve this example, all of you. If time for 75% completion is 5 minutes in a zero order reaction, then time for 50% completion is how much? Time for 75% completion. We have the rate equation, integrated rate equation. For zero order reaction, what was the integrated equation? Concentration of A at any time is equals to concentration of A at time t is equal to 0 minus K into T. 75% completion means how much is left out? 25%. So 25 by 100 into initial concentration is equals to initial concentration minus K into T 75% completion. So T 75% completion is how much? K into T 75% is equals to 1 by 4 times that of. So 3 into concentration of A time T is equal to 0 divided by 4. So T 75% is equals to 3 by 4 K times that of concentration of A naught. So time given 5 minutes. So 5 is equals to 3 by 4 into K into concentration of A time T, concentration of A. So I can write from here what I can write? Concentration of A at time T is equal to 0 divided by K is equals to 20 by 3. What is T half? T half is equals to concentration of A time T is equal to 0 by 2K. That is half of this. That is 10 by 3, which is nothing but 3.33 minutes. 20 by 3 is the time taken for the time required for the completion of 75%. Like concentration of A naught by K is 20 by 3, which is obtained by using this formula T 75% is equal to 3 by 4K into concentration of A at time T is equal to 0. From there, you have to calculate the T half. T half is concentration of A at time T is equal to 0 by 2K. So that is 3.33 minutes. What will be the remaining concentration of reactant A at a T 7 by 8 if initial concentration is A naught? What will be the remaining concentration? Remaining concentration is what? Concentration of A at time T is equals to concentration of A at time T is equal to 0 minus K into T. T 7 by 8 means what? Initial concentration is A naught, T 7 by 8. And this formula, is it required? So T 7 by 8 means 7 by 8 part of the reaction has been consumed. So initial reactant concentration left out. T 7 by 8 means 7 by 8, 7 by 8th part of reactant is consumed. Therefore, concentration of the reactant left out. Reactant concentration left out is equals to 1 minus 7 by 8 times that of initial concentration, that is 1 by 8 A naught. Very simple question. This is all about zero order reactions. Let us proceed with the first order reaction. First order reaction means first you have to think about the examples. Reactions in which rate of the reaction is directly proportional to concentration of reactant are said to be first order reactions. 2N2O5 gives rise to 4NO2 plus O2. NH4NO2 gives rise to N2 plus 2NO2. Hydrolysis of ester in the acidic medium, that is a pseudo first order reaction. 2H2O2 gives rise to 2H2O2, 2H2O and O2, and all the radioactive decay. These are your first order reactions. Like if you go with the equations, so I can write the reaction A gives rise to product is a first order reaction. Rate of this reaction is equals to K into concentration of reactant whole power 1. rate of that reaction is equals to minus d concentration of A divided by dt. And these two I am going to equate. So minus d concentration of A divided by dt is equals to K into concentration of A whole power 1. So I can rearrange this equation. 1 by concentration of A into d concentration of A is equals to minus K into dt. So if I can do the integration from where to where? Time t is equal to 0 to any time t is equal to t. At time t is equal to 0, what was the concentration of A? Concentration of A naught. At time t is equal to t, what was the concentration of A? Concentration of AT. Integral 1 by x dx is what? Integral 1 by x dx.
ln x.
Ln x. Ln means logarithm to the base e. So ln of concentration of A, upper limit and lower limit, you have to substitute after that. The next step will do it. Minus k into t, integral dt is t. Lower limit time t is equal to 0 to upper limit t. So ln of concentration of A at any time minus ln of concentration of A at time t is equal to 0 is equals to minus k into t minus 0. I can write the equation as ln of concentration of A at any time divided by concentration of A at time t is equal to 0 is equals to minus kt, or you can rearrange this equation as concentration of A at any time is equals to concentration of A at time t is equal to 0 into e power minus kt. So how the concentration of A varies as time proceeds. If you try to plot a graph, concentration of A at any time at time t is equal to 0, e power 0 is anything but 0 is 1. So at time t is equal to 0, we have maximum concentration, that is concentration of A naught. After that, you have an exponential decrease. This is versus time. Is that clear? The concentration of A at any time is equals to concentration of A at time t is equal to 0. Concentration of A at time t is equal to 0 into e power minus kt. This was the function. Now instead of logarithm, I can also, instead of writing it in this fashion, we can also write in the other way. Let us proceed with that. Like we have this expression ln of concentration of A at any time divided by concentration of A at time t is equal to 0. Ln of concentration of A at any time divided by concentration of A at time t is equal to 0 is equals to minus k into t. I can rearrange this equation as logarithm. So 2, like I can take the reciprocal, so I can convert the minus sign to plus sign. So 2.303 logarithm of concentration of A at time t is equal to 0 by concentration of A at time t is equal to t is equals to plus k into t. I have reciprocal and I have multiplied with 2.303. So I have written logarithm. So concentration of A at time t is equal to 0, let us say A. Concentration of A at time t is equal to t is A minus x. So you will get what? 2.303 into logarithm of A by A minus x is equals to k into t. This is also the other form of writing your first order reaction rate equation. And you can also plot a graph between like ln of concentration of A at time t versus t. Like ln of concentration of A at time t versus time. If you try to plot a graph, so from here you can write ln of concentration of A at time t is equal to ln of concentration of A at any time minus kt. So slope you will get negative. So this will be the graph. So slope is equals to what for this straight line?
Minus k.
Slope will be is equals to minus k. That will be is equals to tan theta. So theta belongs to quadrant 2. And what is the y-intercept?
ln a naught.
ln a naught. Very good. So you have rate versus concentration. Rate of the reaction versus concentration. First graph, if you think of rate versus concentration as it is a first order reaction, rate of the reaction is directly proportional to concentration. So you'll have a straight line passing through origin. So slope will be is equals to k. Calculation of rate constant. Let us take the reaction A gives rise to product. You get the same equation whatever you have derived. ln concentration A at any time is equals to ln concentration of A at time t is equal to 0 minus kT. If you try to plot a graph of ln concentration of A at any time versus time, you have y is equal to mx plus c, slope is equals to minus k, and y-intercept is ln of concentration of A naught. ln concentration of A at any time, if you take on the y-axis and time on the x-axis, ln concentration of A naught, that is the y-intercept, slope is equals to minus k. ln concentration of A at any time is equals to ln concentration of A naught minus kT. Again, you can convert into logarithm and you can write the expression also. So kT is equal to 2.303. Any format I can write. kT is equal to 2.303 log of concentration of A time t is equal to 0 by concentration of at any time to the base 10, or kT is equal to 2.303 logarithm of A by A minus x. 2.303 logarithm of A by A minus x. Logarithm of A minus x we have taken on the y-axis, time we have taken on the x-axis. If you try to plot a graph, you will get what? Logarithm of A minus x we have taken, like earlier we have plotted with ln of concentration of A at any time t. Now we have plotting with logarithm. Logarithm of A minus x is equal to log A minus kt by 2.03. So intercept is log A, y-intercept is log A, whereas the slope is minus k by 2.303. Slope is going to be changed now. Slope is equals to minus k by 2.303 because it is the graph plotted with the logarithm of A minus x versus t. Earlier we have a graph plotted with ln of concentration of A at any time versus t. So there was a difference between these two. Slope is equals to minus k by 2.303. This is your respective graph and the curve, like straight line with a slope minus k by 2.03 with the intercept logarithm of A to the base 10. Is everything clear, students, so far?
Yes, sir.
Yes, very good. From equation 1, again you can write in the exponential format. This exponential format is the first equation which you have written, if you remember. Concentration of A at any time is equal to concentration of A at time t is equal to 0 into e power minus kt. So this is also called as Wilhelmy equation. So concentration of A at any time versus time, if you try to plot, you will have an exponential decrease in the reactant concentration as time proceeds. We have already written earlier the concentration of reactants decreasing exponentially, products increasing exponentially. How? From this equation only. What are the units of rate constant for first order reaction?
Second inverse, time inverse.
Yeah, time inverse or second inverse, you can say. K is equals to time inverse. You can take second inverse, minute inverse, hour inverse. That depends upon what unit they have given to you. Half-life period, how we can write half-life period? Kt is equals to 2.303 into logarithm of A by A minus x.
A by A minus
So T half is equals to 2.303 by K into logarithm of A by A minus A by 2, because half-life, half of the reactant has been converted. So 2.303 by K into logarithm of A by A minus A by 2 is again A by 2. So A by A by 2 is 2. Log 2 is how much? 0.3010. 0.3010 into 2.303, nothing but
Point
0.
six nine three two.
Yeah, 0.693 divided by K. So T half is not depending upon initial concentration. If you try to plot a graph between T half and initial concentration, what type of curve you are going to get?
Constant.
constant.
You will get a straight line parallel to x-axis. The time in which half of the initial amount of reactance has been done. So you can have T half is equal to 0.693 by K. So if you try to plot a graph of T half versus initial concentration, you will get a straight line parallel to x-axis, because although you try to change the concentration, initial concentration, the T half half-life period is not going to be changed. Half-life period for first order reaction is independent of initial concentration, whereas for zero order reaction, For zero order reaction, T half is directly proportional to initial concentration. T half is equal to
K by
initial
2.
concentration by 2K. Right? Yes. Time for 3/4 of the reaction, T3 by 4. How you can write T3 by 4? You can say T3 by 4 is equal to 3/4 of the reaction has been done. So 2.303 by K into logarithm of A by A minus X, A by A minus 3A by 4. So T3 by 4 is equals to 2.303 by K into logarithm of A by A minus 3A by 4 is A minus 3A by 4 is A by 4. A by A by 4
4A
is
by A.
log 4. Can I write log 4? A by A by 4. So T3 by 4 is nothing but 2.303, 2 times that of 2.303 into log 2 divided by K. Log 2 into 2.303 is 0.693. So T3 by 4 is equals to 2 times that of 0.693 by K. 0.693 by K is nothing but T half. So 3/4 of the reaction. For completion of 3/4 of the reaction, we require 2 half-lives. This is the scenario in the first order reaction, but in the zero order reaction, 2 half-lives. In 2 half-lives, the 100% of the reaction is done. In the zero order reaction, in 2 half-lives, 100% of the reaction is completed. Whereas in the first order reaction, to complete 3/4 of the reaction, we require 2 half-lives. So can I say what is the time required for 100% completion in the first order reaction? What is T 100%? T 100% in first order is how much? Try to figure it out. T3 by 4 is 2 times that of T half. T3 by 4 for first order reaction is independent of initial concentration because T half is independent. And it is 2 times that of T half. And what is T 100%? T 100% means what?
A minus X would be 0.
A minus X would be 0. Can I say concentration of A at any time T is equal to concentration of A at time T is equal to 0 into e power minus K into T. So this is going to be 0. Concentration of A at time T has to be 0 because it is 100% done. Concentration of A at time T is equal to 0. That is equal to concentration of A at time T is equal to 0 into e power minus K into T 100%. When is this going to happen? 0 is equals to e power minus K into T. What should be time?
Infinite.
Infinite. So at time T is equal to infinite only, the first order reaction is going to be complete. That means first order reaction completes 100% in a very large time interval. T is equal to infinite means practically we are saying it will be done in very large time interval. At time T is equal to infinite only, the first order reaction is going to be complete. That means it takes very large time for the first order reactions to be done. Interval formula. Interval formula are useful whenever we are calculating with respect to 2 time intervals. Like from the time T is equal to 0, time T is equal to 0 one scenario, time T is equal to T another scenario. Time T is equal to 0 one scenario, time T is equal to T2, T1 one scenario, T2 other scenario. So with respect to these 2 time intervals also we can calculate. How we can get the relation means we can just look at this. A to 0, concentration at time T is equal to 0, A is equal to A naught, product is 0. A minus X is concentration of A at any time, product concentration is X. We have this formula, Kt is equal to 2.303 logarithm of concentration of A at time T is equal to 0 divided by concentration of A at time T is equal to T. We can do the same. We can write the same as K into T minus 0 is equal to 2.303 into logarithm of concentration of A at time T is equal to 0 divided by concentration of A at time T. Understand this consequence. Concentration at time T is equal to T1 second is concentration of AT1, that is A minus X2. Concentration at time T is equal to T2 second is A minus X2, that is concentration of A at time T2, and X2 is the product form. Then I can write the formula K into T2 minus T1. Between these two intervals I can write K into, earlier between these two intervals we have written 0 to T1, K into T minus 0 is equal to 2.303 into logarithm of concentration of A initially divided by concentration of A at time T. Between these two intervals how I can write K into, between these two intervals of time, how much time is elapsed? T2 minus T1 seconds. That is equal to 2.303 logarithm of concentration of a time T2 divided by concentration of a time T1 divided by concentration of a time T2. It is not something new. It is the same formula. Like you can apply a time T1. This is the concentration. So what is our formula? K into T1 is equals to 2.303 into logarithm of concentration of a time T is equal to 0 by concentration of a time T1. K into T2 is equals to, because from here to here time is T1. From here to here, starting to concentration of a T2, time is T2. So K into T2 is equals to 2.303 logarithm of concentration of a time T is equal to 0 by concentration of a time T is equal to T2. I can write this as equation 2. I can write this as equation 1. I am writing 2 minus 1 now. 2 minus 1 gives K into T2 minus K into T1 is equals to 2.303 into logarithm of concentration of a time 0 divided by concentration of a time T2 minus logarithm of concentration of a time 0 divided by concentration of a time T1. What you will get? K into T2 minus T1 is equals to 2.303 into log A naught minus log concentration AT. Logarithm of concentration of A naught minus logarithm of concentration of AT, log A by B, minus log A naught, minus into minus becomes plus log concentration of A at time T1. This is a time T2. Here log A naught minus log A naught get cancels out. You will get ultimately what? This formula or not? Therefore, K into T2 minus T1 is equals to 2.303 logarithm of concentration of A at time T1 divided by concentration of A at time T2. So this was your ultimate formula. So you can get this formula by solving these two equations 2 times. Instead of solving these two equations for 2 times, you can directly know the interval formula. Like at time T is equal to 0, reaction started. At time T is equal to 5 seconds, this is the concentration of the reactant. At time T is equal to 10 seconds, this is the concentration of the reactant. What is the value of K? Like that questions can be asked. So directly I can apply this formula. K into 10 minus 5 is equal to 2.303 logarithm of these two concentrations are substituted. If you have to do that by general method, you have to solve two equations. Okay, which is time consuming. Right? K is equal to 2.303 by T2 minus T1 into logarithm of A minus x1 by A minus x2. That is nothing but your interval formula, where x1 and x2 are the amount consumed at time T1 and T2 respectively. Like short conclusion for first order reaction. Like initial concentration is 100 molar, T1 T half it becomes 50 molar. So it is nothing but T half or 50% done. In one more T half, 50 molar becomes how many molar?
25.
25 molar. 50% has to be done. 100 molar if I start. In one T half it becomes 50 molar. 50 molar becomes 25 molar in one more T half. So from the initial time, how much time has been done? Like initial 100 molar to 25 molar.
2 T half.
Like
2
75% has been done. Yeah, 2 T half is nothing but 75%. 25 molar to 12.5 molar, again one more T half. So 3 T half has been done, 87.5%. 87.5% has been done. 12.5 molar to 6.25 molar, one more T half, 4 T half. So you'll have 93.75%. 93.75% of the reaction has been done. Like that, you can proceed. You can proceed in a infinite time. 100% of the reaction is going to be done. If you proceed in this manner, in infinite time, 100% of the reaction is going to be done. T 3 by 4 is T 75%, that is 2 T half. T 7 by 8 is T 87.5, that is 3 T half. T 15 by 16 is T 93.75%, that is 4 T half. Similarly, T 99.9% completion is 10 T half. T 99.9% completion is 10 T half. This is the formula shortcut which you can remember if you want. If you don't want, you can directly solve. These are not a formula to different formula to remember. You can directly have the equation K into T is equal to 2.303 logarithm of a by a minus x. Substitute it, get the answer. This is the only formula you should remember. Time required for completion of definite fraction of first order reaction is fixed and it is independent of initial concentration of reactant. So I can say remaining amount of reactant after time is concentration of A after time t is equal to initial concentration divided by 2 power n. Concentration of A after time t is equals to initial concentration divided by 2 power n. Yeah, try to understand all of you. I'll be sharing the handouts to you. Okay. Try to understand the concept. All of you, handouts I'll share. If you have any doubt, you are free to ask at any time of the class. Right, short conclusion for first order reaction. Time required for completion of definite fraction of the first order reaction is fixed and it is independent of the initial concentration of reactant. That means like in 1 T half, the concentration of A become what? In 1 T half it become half. In next T half it become again half. Again half. Like that it is going to become half and half and half. Yes or no? Concentration of A after time t is equals to initial concentration divided by T half divided by 2 power n we can write, or n number of T half is equal to total time divided by T half. You can write this derivation. Concentration of A at any time is equals to initial concentration divided by 2 power n, because initially I have 100, 100 to 50, 50 to 25, 25 to 12.5, 12.5 to 6.25. It is 1 T half, other T half, this other T half, this other T half. 4 T half I have done. So initial concentration 100. So concentration of A after time 4 T half is equals to initial concentration divided by how many T halves? 1, 2, 3, 4. 2 power
4.
4. How much is that? 100 by
16.
2 power 4 is 16. Do the calculation. You will get 6.25 or not.
Yes, sir.
Yes or no? So concentration of A after time t is equals to initial concentration divided by 2 power n. That was the formula. And number of T halves you can calculate by total time divided by T half. N is nothing but number of T halves. The total time divided by T half is nothing but the number. So let us try to solve some questions. You will get more clarity. How much time is required for the conversion of reactant from 10 gram to 1.25 gram in first order reaction? So 10 gram is converting into 1.25 gram. T half is 10 minutes. How much time is required? Try to solve. 10 gram is going to be converting into 1.25 gram in how much time? Without using the formula, you can solve. Without using the formula also, you can solve. With using the formula, everyone can solve. 10 gram is going to be converted to, because they have given T half, no. 10 gram will become 5 gram in how much time? 10 minutes. 5 gram will become 2.5 gram in how much time? One more 10 minutes.
10 minutes.
2.5 to 1.25 gram in again 10 minutes. So 10 gram to 1.25 becomes in how much time? 10 plus 10 plus 10? 30 minutes. Yes or no? 10 gram of the reactant will be converting into 1.25 gram in how much time? 30 minutes of time. Try to solve this. The time passed between 33.3% completion and 66.7% completion. Is the previous question clear to everyone or not?
Yes, sir. Yes, sir.
Yes, right. Try to solve this question. The time passed between 33.3% completion and 66.7% completion in first order reaction is 30 minutes. Find the approximate time in which reaction will be 25% completed. So 33.3% is done. So concentration of A, where 33.3% is done, is initial concentration minus 33.3 divided by 100 into initial concentration. How much is that? 100 minus 33.3.
66.7.
66.7 by 100 into concentration of A time t is equal to 0. Concentration of A, where 66.7% is done, is initial concentration minus 66.7 by 100 times that of initial concentration. How much is that going to be? 33.3 by 100 into 100%. So let us take 33.3% completed in t1 seconds. So time t1 is equals to 2.303 by k into logarithm of initial concentration of A time t is equal to 0 by concentration of A time 33.3%. So what is T1? T1 is equals to 2.303 by K log concentration of A divided by 66.7 by 100
A naught.
A naught. Very good. Similarly, 66.7% is done in T2 time. So I can write T2 is equals to 2.303 by K.
Log A naught
Yes.
by
A naught by 33.3 by 100.
into A naught.
Very good. So they said that time passed between 33.3% completion and 66.7% completion is 30 minutes. That means T2 minus T1 is 30 minutes or not?
Yes.
Yes.
T2 is the time from 0 to 66.7. T1 is the time from 0 to 66.7 is T2. 0 to
33.3.
33.3% is T1. So T2 minus T1 is between 66.7 to 33.3. So T2 minus T1 is equal to 30 minutes. T2 minus T1, you try to calculate what is T2 minus T1. 2.303 by K, I can take common. 2.303 by K, I can take common into logarithm of 100 by 33.3. Logarithm of 100 by 33.3 minus logarithm of
100
by
by 66.7.
66.7. That is equals to respective 30 minutes.
30.
So log 100 gets cancels out. So what you'll get? 2.303 by K into logarithm of, if you try to rearrange, you can write this as log 100 by 33.3 is log 100 minus log 33.3 minus of log 100 minus log 66.7. So I'll get logarithm of plus log 66.7 minus log 33.3. So log 66.7 by 33.3 I can write. Is that understood or not? This step, from this step to this step.
Yes, sir.
Log 100 gets cancels out. Minus log 33.3 plus log 66.7. That becomes log 66.7 by 33.3. That is equal to 30. 33.3, 66.7. Approximately how many times cancels out?
2.
2 times or not?
2 times.
So 2.303 into 2 log 2 is 0.693 by K is equals to 30. So K is equals to 0.693 by 30. But they are asking what? Find the approximate time in which 25% is done. So T 25% is 2.303 by K
by
into logarithm
log
of concentration of A time T is equal to 0. 25% is done is 70% left out. So 3 by 4 concentration of A time T is equal to 0.
A naught.
A naught gets cancels out. Ultimately you get what? 2.303 by K is how much?
By K.
0.693 by
693. 30 log log 4
by
minus
3.
log 3.
Log 4 minus log 3. Solve it. Faizan says nearly 35 minutes. You try to solve it, you get the answer. For simple calculations, you can write 0.693 as how much? For simple calculations, you can also write 2.303 into 30. 0.693 is nothing but 2.303 into log 2, right?
Yes, sir.
Do log 4 minus log 3. So 2.00 get cancels out. You have 30 by log 2, 30 by 0.3010 into log 4 minus log 3. Do this, that is your answer. Calculation, it's your part, you have to do it. Right? Try to solve this question. If the rate constant for the first order reaction is given as 2.303 second inverse, they said first order reaction, and initial concentration of reactant is 1 molar. Find out percentage of initial concentration of reactant that will convert into product after 1 second, and also find out rate of reaction at that time. Find out the percentage of initial concentration of reactant that will convert into product after 1 second, and also find out the rate of reaction at that particular time. So we have the equation. What is our equation? K is equals to 2.303 by T
by T
into logarithm of
log A by A minus
A
6.
by A minus X. Or you can say concentration of A times 0 divided by concentration of A time T. Concentration of A time T is equal to 0 divided by concentration of A time T is equal to T. If the rate constant of the reaction is given as 2.03, initial concentration of reactant is 1 molar. So substitute that. Rate constant is 2.303.
2.303 is equal to 2.303 by T
T. How
log
much time? How much time? Find out the percentage of initial concentration of reactant that will convert to product after 1 second. So time T is equal to
1 second.
1 second.
1 second.
1 second. What is the initial concentration?
1 molar.
1 molar divided by concentration of a time T. So only this thing is only concentration of a time T is the unknown that you can calculate. So 2.33 gets cancels out. You get 1 is equals to logarithm of
log
1 by concentration of a time T. So can I say 1 is equal to log X? So X should be is equal to log X is equal to 1 means X is equals to 10 because log 10 is 1. So 1 by
Yes.
concentration of a time T is 10. So from here I can write concentration of a time T is 1 by 10. Concentration of a time T is 1 by 10. How I can write? That I can write as 10 by 100 into 1 molar or not. So 10 by 100 into 1 molar is nothing but concentration of a time T is equals to 10 by 100 times that of 1 molar is initial concentration. So what happened? How much is converted? Therefore, 10% of reactant is converted. Concentration of A time T is 10% of the initial reactant. So how much is converted? 10% converted, 90%, 90% converted. Find out the percentage of initial concentration of reactant that will convert into product after 1 second. After 1 second, what is the concentration of A time T? Left out concentration is 10% of initial concentration. 10% of the reactant is present after 1 second. So 90% should be converted. Yes or no?
Yes, sir.
Yes.
Yes, sir.
10% of the reaction is left out after time T. So 90% should be converted, and also find the rate of reaction at that time. What is rate? Rate is equal to K into concentration of A.
Concentration.
Rate of reaction at time t is equal to 1 second is K into concentration of A at time t is equal to 1 second. So K is given as 2.303. Concentration of A at time t is equal to 1 second is how much? At time t is equal to 1 second, concentration of A is 1 by 10. So 0.2303. This is the rate. Rate of the reaction at time t is equal to 1 second is at that time is 0.2303 because rate is equals to K into concentration of A power 1 only because it is a first order reaction. Right? This is simple question. So no need to complicate it all, but understand the question and what they are asking. That you have to read the question carefully, then only you'll get right answers. Next question. For a gaseous reaction, A gives rise to products like A gaseous gives rise to B gaseous plus C gaseous plus D gaseous. If the pressure of the reactant is P naught and after time t the total pressure of gaseous mixture is Pt, then calculate the rate constant for the first order reaction. A is a gas converting into B gas plus C gas plus a D gas. At time t is equal to 0, since all are gases, A, B, C, and D, that is all the reactants and products are gases. At time t is equal to 0, what was the, if initial pressure of reactant is P naught, B is 0, C 0, D 0. At time t is equal to T, let us say, from this equation I can say 1 mole of A, if 1 mole of A is lost, it forms how many moles of B, how many moles of C, and how many moles of D?
1/3
1
moles each.
1 by 3 moles each. Sure, Fatima?
1 mole.
1 mole each.
1 mole, no? So A, 1 mole is producing 1 mole of B and 1 mole of C and 1 mole of D. 1 mole of A is producing 1 mole of B, 1 mole of C and 1 mole of D. So the pressure lost by A is like, let us say P dash. So P dash is the pressure lost by A. So P naught minus P dash. So if P dash is the pressure lost by A, since 1 mole of A is producing only 1 mole of B, what is the pressure gained or developed by B? P dash. Similarly, what is the pressure developed by C? P dash.
B dash.
And D is
P
also P dash.
dash.
If somewhere here we have some 2 moles of B, 3 moles of C, then you will get 2 P dash, 3 P dash. But we don't have that, so we'll have this equation only. Or let us change the equation. Can we change the equation to 2 moles of B and 3 moles of C? Can we change it? Because you will have different, no? Because A, B, and C, like B, C, and D, all the products 1 mole, then you will have simple scenario. Let us change the equation. A gas gives us to 2B gas plus 3C gas plus D gas. So P naught minus P dash. So what is the pressure developed in B? 2P dash. What is the pressure developed in C? 3P dash. And D, only 1 mole is obtained, so P dash. And what they are saying, if the initial pressure of reactant is P naught and after time t, the total pressure of the gaseous reaction is Pt. They are saying after time t, total pressure is what? Total pressure is equals to Pt. What is total pressure? Pressure due to A plus pressure due to B plus pressure due to C plus pressure due to D. That is equals to Pt. What is the pressure due to A? P naught minus P dash.
P dash.
Pressure due to B, 2P dash.
2 P dash. 3 P
3P dash
dash.
plus P dash is equals to
P
P dash.
dash.
So I can write down this as minus P dash plus
P
P dash
naught.
cancel out.
P naught plus 5 P dash
P
is
naught
equals
plus
to P
5 P dash is equals to Pt. Did they mention anything regarding P dash, or P dash is a variable which we have introduced?
No, sir.
P dash is a variable which we have introduced. So we have to eliminate P dash. We can't report the rate constant in terms of P dash because they have mentioned if initial pressure of the reactant is P naught and after time t the total pressure is Pt. So P dash is something which we have introduced. So that P dash is equals to, that we have to eliminate. We can't keep in the equation. So P dash is equals to Pt minus P naught divided by 5. So what is your rate constant K? From the first order reaction, K is equals to 2.303 by T
T
to logarithm
log
of concentration of
initial
reactant at,
concentration.
yeah, initial pressure we can say here. Initial pressure is P naught
Yes, sir.
by pressure after some time
By
is P naught minus P dash.
P minus P
So
dash.
P dash we have to eliminate. So 2.303 by T to logarithm of what is P naught minus P dash? P naught divided by P naught minus P dash is how much? P dash is Pt minus P naught whole divided by 5. So K is how much? K is equals to 2.303 by T
303 by T.
into logarithm of 5 P naught divided by 5 P naught minus Pt minus into minus plus 6 P naught.
6
So
P naught minus PT.
6 P naught minus Pt. This is the expression. Okay. For a gaseous reaction like A gaseous gives rise to 2B gaseous plus 3C gaseous plus D gaseous, you are not supposed to include this P dash because P dash is a variable which we have introduced, so we have to remove it from the final equation. Is that clear to everyone or not?
Yes, sir.
Yes, sir.
This is also similar question. 2A gives rise to 3B plus C. Same type of question. Let us solve it again. 2A gives rise to 3B gaseous plus C solid. At time t is equal to C, let us say P naught is the pressure because they have given what? With the initial pressure of P naught. Yeah.
0,
Time t
0.
is equal to T. Time t is equal to T.
P
What is the
naught
pressure of A?
minus
P dash.
P dash.
What is the pressure developed due to B?
3 P dash.
3 P dash or 3 by 2 P dash?
By 2
3 by 2 P dash.
For 2 moles of A, you are getting 3 moles of B. For 1 mole of A, you will get 3 by 2 mole of B. So you will get 3 by 2 P dash. What is the pressure due to C?
P dash. P dash by 2.
P dash by
P dash by 2. Sure? Or 0? C is a solid.
0, sir. Solid.
Okay. C is a solid, so it should be 0. So you have to take care carefully about the type of physical state given to you. Whenever we have gases, only then we have to include those pressures. So PT is equals to the total pressure is PT, that is partial pair of A plus partial pair of B. That is equals to PT is equals to partial pair of A is P naught minus P dash. Partial pair of B is 3 by 2 P dash. So PT is equals to P naught plus 1 by 2 P dash. So from here I can eliminate P dash. So I can write a P dash as 2 times that of PT minus P naught. PT minus P naught into 2 is nothing but P dash. So what is the rate constant K? K is equals to 2.303 by T into logarithm of
P naught by
P naught by P naught minus P dash. Because pressure of A at time T is equal to 0 divided by pressure of A after some time T. So K is equals to 2.303 by T
2.303 by T.
by
Log
logarithm of
P
P
naught
naught by
by
P naught minus
P
P
naught
dash. P dash how
minus
you can
P
write?
naught.
Minus
P
2 PT
P
minus into minus become plus 2 P dot.
minus
So K is equals to 2.303 by T into logarithm of P naught divided by 3 P naught minus 2 PT.
minus 2 P.
Yes or no?
Yes, sir.
So these are your equations, students. And first order kinetics in terms of volume. So in terms of volume, if you try to figure out, so we'll have this is the equation. So earlier our equation was KT is equals to 2.303
2.303
logarithm of
log
A by
A
A
naught
minus X.
A
So can I
minus
write
X.
as A minus 0 by A minus X?
Yes, sir.
Yes or no? Same similar equation you are going to have. KT is equal to 2.303 into logarithm of V infinite minus V0 divided by V infinite minus VT. V infinite is volume of the gas at the end of the reaction. Once the reaction is completely done, how much volume is there? That is V infinite. Vt is volume of gas at time t. V naught is volume of gas at time t is equal to 0. At time t is equal to 0, how much volume is there? At time t is equal to infinite, how much volume is there? Time t is equal to 0 to time t is equal to infinite, what is the volume change? That you have to take in the numerator. Time t is equal to 0 to time t is equal to infinite, volume change. Time t is equal to t dash to, like t is equal to 0, t is equal to t, t is equal to infinite. V naught, V infinite, Vt. So this is your V infinite minus V naught. This is your V infinite minus Vt. So V infinite minus Vt is the volume change for infinite time and time t is equal to 0. V infinite minus Vt is the volume change for infinite and time t is equal to t. So whenever you try to calculate with respect to these two quantities, you will get this change from V naught to Vt, how much is the change done, and from that you will get the equation. So 2.303 logarithm of V infinite minus V naught by V infinite minus Vt. That is your first order kinetics in terms of volume. Solve this question. Decomposition of N2O5 is a first order reaction. Decomposition of N2O5 occurs in this way. N2O5 gives N2O4 plus half mole of O2. After 15 minutes, the volume of O2 gas is 9 ml. 15 minutes, time t is equals to 15 minutes. Volume of O2 is 9 ml. And after a very long time, very long time is time t is equal to infinite.
Infinity. V
Volume of
infinity.
O2 is 35 ml.
35.
And volume of O2 at time t is equal to 0. What is the volume of O2 at time t is equal to 0? 0 ml, because O2 is a
0.
product. So we have the formula K into T is equals to 2.303 into logarithm
303
of,
log V infinity minus V naught by V infinity minus Vt.
is very good. So try to substitute everything now. So we have to find out rate constant K. So K into, what is the time? 15 minutes
Time 15 minutes.
is equals to 2.303 into logarithm of, what is V infinite? 35 minus 0 divided
35
by
minus 0 by
35
35
minus
minus
9.
9.
Right. K is equals to 2.303 by 15 into logarithm of 35 by 26.
35. Yes.
How we can write down 35 by 26? Log 35 minus log 26. 35, how can calculate log 35?
1.54.
Log 7, like 35 I can write as 7
5
into 5.
7. 5 into 7.
Yeah, log 7 plus log 5. Log 30, log 26 we have to approximate. 26 you can write as 13 into 2.
13 into 2. Yes.
So that 13 you don't write, you have to approximate that value. Or you can just look for other conversions. Any other conversions you can have? 26. Can you convert 26? Like 260 by 5 is how much? 260 by 2 is 135, right? 135 you try to write in other fractions. How can you write 135 in other fractions? 135 or
15
125?
9, so 135.
135 or 125? 130.
120.
130.
130, sir.
Yes. So you have to approximate then, because 13 you are getting right. So you can approximate to log 12. Whenever you can't approximate, you can't find the value of approximate, then you can do log 13 you can take as log 12 plus log 14 divided by 2. Average value you can consider. In case if the values are not given to you and there is no other way possibility to find out it, then you can do it approximate in that way. Next is general integrated rate equation for the nth order kinetics. Nth order kinetics means what? Rate is equals to K into concentration of a whole per n. Rate is equals to minus d concentration of A by dt. This is for the reaction A gives rise to product if it is nth order. So I can write the equation minus d concentration of A divided by dt is equals to K into concentration of A whole per n. So I can rearrange it 1 by concentration of A whole power n is into dA, d concentration of A is equals to minus k into dt. I can integrate from time t is equal to 0 to time t is equal to infinity.
T.
Time t is equal to 0, concentration of A is A naught. Time t is equal to d, concentration of A is concentration of AT. Integration is nothing but summation. So 1 by concentration of A whole power n. What is the integral? Integral x power n
ln
dx. ln. Integral x power n dx. What is the formula?
nx
X to the power n
X
plus 1
plus
upon
1
n
by
plus
n
1.
plus 1.
X to the power of n plus 1 by n plus 1. Here you can use a similar formula. I can write concentration of A whole power minus n. So in concentration of A whole power minus n plus 1 whole divided by minus n plus 1. Concentration of A time t is equal to 0. Concentration of A at any time is equals to minus k into t. Time varies from t is equal to 0 to t is equal to t. So this minus I am bringing to the other side. So I can write 1 by n minus 1. 1 by n minus 1 into concentration of A. Like I'll write this down as 1 by concentration of A time t whole power 1 minus n minus 1 by concentration of A time t is equal to 0 whole power 1 minus n is equals to minus the I have brought to the other side, so plus k into t. So this was your function. Is that clear or not? Any calculation mistake? If you find out, you can let me know. Kt is equals to 1 by n minus 1 into concentration of A time t whole power 1 minus n. You are getting n minus 1 here. Check it out once. Yes, in the like I'm taking the reciprocal, right? So earlier a
Yes.
concentration of A whole power minus n plus 1. I'm taking the reciprocal. So I have to write n minus 1. Earlier I have concentration of A whole power minus n plus 1, 1 minus n. But I'm writing in the denominator. So I have to write n minus 1. 1 by concentration of A at any time power n minus 1 minus 1 by concentration of A time t is equal to 0 power n minus 1. That will be is equals to Kt. This was your correct equation. If time t is equal to half, how we can calculate? At time t is equal to half, can I say concentration of A time t is equal to initial concentration by 2? This equation we have derived just by doing simple integration. So at time t is equal to half, concentration of A at any time is equal to concentration of A at time t is equal to 0 by 2. So k into t half is equals to 1 by n minus 1 into concentration of A at any time. You can write as concentration of A at time t is equal to 0 by 2. So you can write it as 2 by concentration of A at time t is equal to 0 whole power n minus 1 minus 1 by concentration of A at time t is equal to 0 power n minus 1. So k into t half is equals to 1 by n minus 1 whole multiplied by 2 power n minus 1 whole divided by concentration of A time t is equal to 0 power n minus 1. So this was the formula you're getting. So t half is inversely proportional to, understand this point carefully. Here also n should not be equal to 1. If n is equal to 1, what is our formula? What is the issue?
T half would be 0.
If n equal to 1, this t half would be 0 or infinite?
Infinity.
In-
Point.
Yes or no? If n is equal to 1, then it becomes a first order reaction or not?
Yes.
If n is equal to 1, this is nth order reaction. If it is a first order reaction, you will get a formula integral 1 by x dx. This formula is valid. Integral x power n dx is equal to x power n plus 1 by n plus 1. This formula is only valid for n not equal to minus 1. If n equal to minus 1, it becomes integral 1 by x dx. That is ln x. Yes or no? Under the mathematical analogy, we can say integral x power n dx is equal to x power n plus 1 by n plus 1 plus c only when n not equal to minus 1. If n equal to minus 1, it becomes integral x power minus 1 dx, that is integral 1 by x dx, which is log x. So from here, what I can write, t half is directly proportional to 1 by initial concentration power n minus 1, or t half is inversely proportional to initial concentration power n minus 1 is the relation. What is the relation? T half is inversely proportional to inversely proportional to initial concentration of reactant to the power of n minus 1. What is n? N is the order of the reaction. N is the order of reaction. T half is inversely proportional to initial concentration of the reactant to the power of n minus 1, where n is the order of that particular reaction. Right? So with this, using this formula, I can calculate for the second order and third order also. Try to find out. For a reaction, C naught into under root of T half is equal to constant, determine order of the reaction. C naught into under root of T half is equals to some constant K. Some constant you can say. So I'll just squaring on both sides. So C naught power 2
Square.
into T half is equal to some
Constant.
constant. So T half is inversely proportional to
C square.
C naught square. So we know T half is inversely proportional to 1 by C naught power n minus 1. So I can compare n minus 1 is equals to 2. Therefore, n is equals to 3.
N is
So
3.
for what is the order for this reaction? Third order reaction. For a reaction C naught into under root of T half is equal to constant, determine order of the reaction. What is the order for this reaction? The order of this particular reaction is going to be third order. Simple question. Just we have to compare with this formula. T naught is inversely proportional to initial concentration of the reactant. T half is inversely proportional to initial concentration of the reactant raised to the power of n minus 1, where n is the order of the reaction. Try to solve this question. For the given reaction A to B, concentration 10 molar, T half 50 second, concentration 20 molar, T half is again 50 second. Find out the order of reaction. We know T half is inversely proportional to initial concentration. Concentration of air time T is equal to 0 power n minus 1. T half is inversely proportional to initial concentration power n minus 1. Even though I change the initial concentration, is the T half changing?
No, sir.
No, sir.
From this, what you can understand?
Independent of initial concentration.
So n minus 1 should be is equals to n minus 1 should be is equal to
0.
what? Because even though you try to change the initial concentration, T half is not varying. So from that I can easily say initial concentration power n minus 1. So n minus 1 has to be equal to 0. So n is equals to 1. Since T half is independent of initial concentration, I am writing n minus 1 is equals to 0. So n should be is equals to 1. Try to solve this. Or you can see easily say from the previous question what you can say. For the first order reaction, T half is equals to 0.693 by K. So for first order reaction only, the T half is not depending upon initial concentration. So it should be first order reaction directly. If initial concentration of reactant is double, then half-life becomes double. Then order of reaction is
0 order.
0.
0 order.
So T half, yeah, directly you can say 0 order because T half is equals to concentration of A naught by
A by 2K.
From this formula also you can derive the same. T half is inversely proportional to initial concentration power n minus 1. So T half of first case divided by T half of second case is equals to A naught of second case power n minus 1 divided by A naught of first case divided by n minus 1. So T half of first case divided by what is the T half of second case? 2 times that of T half of first case, that is equals to concentration you have doubled, right?
Yes,
So 2
sir.
times that of A naught whole power n minus 1, also 2 power n minus 1 you have, divided by a naught in the first case, power n minus
N
1.
minus
It gets cancelled out, t half gets cancelled out.
1.
2 power minus 1 is equals to 2 power n minus 1. So minus 1 is equals to n minus 1, n is equal to 0. So it is zero order reaction. Right?
Yes, sir.
Yes.
Very good. Try to solve this question as homework, same type of question. T half is inversely proportional to initial concentration power n minus 1. They have given pressures, so you can take pressures. Initial pressure P naught power n minus 1. Okay, with respect to changing P naught, T half is changing. So take two experiments, find out, you will get equations. With respect to two equations, you calculate the value of n. Same type of question, the experimental data is given, substitute the experimental data and calculate the n value. Next, second order reaction. What is the nth order reaction? Kt is equals to 1 by n minus 1 into 1 by concentration of a time t whole power n minus 1 minus 1 by concentration of a time t time 0 whole power n minus 1. Second order means n is equals to 2. N is equals to 2 means k into t is equals to 1 by n minus 1. 1 by 2 minus 1 is 1 by 1. 1 by concentration of a time t power 2 minus 1 is 1 minus 1 by concentration of a time t is equal to 0. So Kt is equals to 1 by concentration of a time t minus 1 by concentration of a time t is equal to 0. So this was the formula which you get. Kt is equals to 1 by concentration of a time t minus 1 by concentration of a time t is equals to 0. From this I can actually plot a graph. 1 by concentration of a time t is equals to 1 by concentration of a time t is equal to 0 plus k into t. If you try to plot a graph taking 1 by concentration of a time t on the y-axis and time on the x-axis, you will get a slope. What will be the slope?
K.
Plus K.
Slope is equals to k, that is equals to tan theta, and the y-intercept is 1 by concentration
1
of
by
a time,
V
1 by a naught. And what about t half? At time t is equal to t half, what happens? 2 by concentration of a time t is equal to 0, like at time t is equal to t half, concentration of a time t is equal to concentration of a time t is equal to 0 by 2. So the 2 comes to the numerator. 2 by concentration of a time t is equals to 1 by concentration of a time t is equal to 0 plus k into t
K
half.
T half.
So t half will be equals to what? 1 by concentration of a at time t is equal to 0 into k. So you get t half is equals to 1 by initial concentration of a into k. So similarly, you can try to plot a graph between t half taking on the y-axis. Like we'll plot the graph in the next page. Example, you can take hydrols of ester by alkali saponification. H2 plus I2 gives 2HI. 2HI forms H2 plus I2. 2NO2 gives 2NO plus O2. All these are examples of second order reaction. All these are different examples of second order reaction. Yes. T half is equals to 1 by concentration of a time t is equal to 0 into k. Here we have a space. Let us plot the graph then. T half, if you take on the y-axis, and 1 by concentration of a naught. If you take on the x-axis, what type of graph you will get?
Direct straight line.
Straight line passing through origin. What will the slope?
1 by K.
1 by K.
By k, that is equals to tan theta. And you plot another graph. You take t half on the y-axis, concentration of a naught on the x-axis. What type of graph you'll get?
Rectangular hyperbola.
Rectangular hyperbola.
Rectangular hyperbola. Very good. Like that, different if you arrange la y coordinate or x coordinate, you will get different types of graphs. Calculation of rate constant, same whatever we have done. So nth order equation we have written. So for second order, n is equals to 2. So kt is equal to 1 by concentration of A time t minus 1 by concentration of A time t is equal to 0. From here you can also write 1 by concentration of A at any time is equals to 1 by concentration of A time t is equal to 0 plus kt. So 1 by concentration of A time t versus t, you get the graph which will have a slope k and which will have a y-intercept 1 by ak. Same graph we have plotted here. Y-intercept 1 by a naught, slope is equals to k. Half-life period at time t is equal to t half. You have t half is equals to 1 by concentration of a naught into k. Again, you try to plot a graph. T half you take on the y-axis, 1 by a naught you take on the x-axis. You will get a straight line passing through origin with a slope of 1 by ak. Like graph, we have to analyze data. From the graph, you have to analyze data like k value you can get or initial concentration you can get. Whenever graphical questions have been given, you should be in a position to analyze the data from the graph, whatever they have given to us. Is everything clear, students, so far?
Yes, sir.
Yes.
Right. So similarly, we can proceed with the third order reaction. Third order reaction means what? Kt is equals to 1 by
is equal to
n minus 1
n minus 1 into 1 by
concentration of
a t power n minus 1 minus 1 by a naught n minus 1.
very good. Kt is equals to 1 by n minus 1 into 1 by concentration of a time t power n minus 1 minus 1 by concentration of a time t is equal to 0 power n minus 1. Now n is equals to third order means n is equal to 3. So Kt is equals
Kt
to
is
1 by
1 by
2
2 into 1 by a t power 2 minus 1 by a naught power 2.
Very good. Kt is equal to half of 1 by concentration of a time t whole square minus 1 by concentration of a at time t is equal to 0 whole square. So if I try to rearrange, I'll get 1 by concentration of a time t whole square is equals to 1 by concentration of a at time t is equal to 0 whole square plus 2 kt. Because 2 I am taking to the other side, 2 kt is equal to 1 by concentration of a time t whole square minus 1 by concentration of a time t is equal to 0 whole square. That I am rearranging, I'll get this expression. So this is your third order integrated rate equation. And if you try to plot a graph between 1 by concentration of a at time t is equal to concentration of a at any time t whole square and time curve versus time, you get a straight line. What is the slope of that straight line?
2K.
2k
2k. That will again be equal to tan theta. And what was the intercept?
1 by a naught
1 by a naught square. Very good. And time t is equal to t half. Concentration of a time t is equals to concentration of a time t is equal to 0 by 2. So we will get what?
4 by not.
4
2
by
by
a naught
4 by 80
4,
uh,
4 by a naught square, right? 80 is a naught by 2.
is is
4 by a naught square is
is
equals to
equals to 1 by a naught square plus 2 kt
2k t half. So what is t half? 3 by
3
By 2K.
n
k a naught square.
n naught square.
Yes. Similarly, if you try to plot a graph, between t half and 1 by a naught square, you will get a straight line. You will get a straight line passing through Passing to origin, the slope of
slope
by 2.
3 by 2k.
3 by 2k, right? T half you have taken on the x-axis, 1 by a naught square on the y. T half you have taken on the y-axis, 1 by a naught square you have taken on the x-axis. You will get a straight line with a slope of 3 by 2k. And one point you need to note down carefully is the second order and third order reaction, whatever we are studying here. In these reactions, both the reactants have equal initial concentration. That point you have to note down. Because I am directly writing how this equation has been obtained, nth order reaction. The nth order reaction equation has been obtained by, like A gives rise to product, I have directly written minus d concentration of A by dt is equals to k into concentration of a whole per n. That means whatever the n reactants have, all the n reactants concentration is same. That we have assumed already. If one reactant or the other reactant have different concentration, then we have a different expression. Like we can also solve for the second order reaction where the concentration is different. Let us try to look at that idea. Like just a second. Whenever the initial concentrations are differed, then whatever the function you are going to get, that will be also differed. That will also be differed. You will study it here. The second order reaction only we'll try to solve. Now the second order reaction is not A gives rise to B. Earlier, what was second order reaction? Earlier our second order reaction is A gives rise to P, where we have written minus d concentration of A by dt is equals to k into concentration of A whole power 2. Yes or no? But now our reaction now is, it is still a second order reaction, but initial concentration of the reactants are different. Like A plus B gives rise to P, but initial concentration of A at time t is equal to 0 is A is A, B is B, and product is 0. At time t is equal to t, for A we'll have A minus x, for B we'll have B minus x, for product we'll have x. Are you getting this idea or not?
Yes.
Yes.
Yes or no? Now you try to do the integration. Now you try to do the integration. Now you try to do the integration. So if you try to do the integration now, you will get a complete different answer. Complete different answer means you will be obviously getting a different answer. Why? The reason why?
Concentration is different.
Because concentrations are different. So try to solve now. So what type of expressions you will be getting, you will have an idea. Try to solve, all of you. Take a minute of time and try to solve it. So such complex questions may not be given, but you have to understand like how the reaction has to be done, how the equation can be written. Anyone got the answer? Like A minus x, B minus x, x is the concentrations at time t is equal to t. When you try to solve this expression further, you will get what? Concentration of A at any time t, like dx by dt you can write. Rate R is equals to dx by dt. Rate R is equals to k into concentration of A into concentration of B. So I can write dx by dt is equals to k into what is the concentration of A at any time t? A minus x. Concentration of B at any time t? B minus
B
x.
minus.
Why I am writing rate is equals to dx by dt? Because there are two reactants A and B whose concentration are different. I can't write minus g concentration of A by dt alone. Then I'll be having only one expression. So with respect to x, I am writing the integration like R is equals to d concentration of x by dt. Rate I can write with respect to increase in the product formation rate, because x is the number of moles of product obtained. So dx by dt is the change in concentration of product by time required for that change. So rate is equal to dx by dt, that is equal to k into A minus x into B minus x. So I can rearrange this equation dx by A minus x into B minus x is equals to k into dt I am getting. So now you do the integration from time t is equal to 0 to time t is equal to t. And here x is the integral, like dx is the x is the variable. So x varies from what is x at time t is equal to 0. At time t is equal to 0, x is equal to 0. X is the amount of reactant converted to product. What is x at time t is equal to t? X is equal to x at time t is equal to t. So integral 1 by A minus x into B minus x. Do you know how to solve it?
Yes.
Just how to solve it, Nandana? Integral.
Let's say you can divide it by 1 by A minus B outside. And then
Yes.
inside you can do A minus X minus B minus X like that.
Very good. So I can just do the partial fractions. Yes or no?
Yes, sir. Yes, sir.
So you can write this as integral of x is equal to 0 to x is equal to x. You can write this as A minus x minus of B minus x divided by A minus x into B minus x into dx. That is equals to integral k, or I'm taking outside k, integral time t is equal to t, time t is equal to 0 to time t is equal to t dt. Here in the numerator we have added a minus b, so I am just dividing with a minus b. So 1 by a minus b into, I'll get an equation now, integral x is equal to 0 to x is equal to x, 1 by b minus x minus integral x is equal to 0 to x is equal to x, 1 by a minus x is equals to k into t, integral dt is t, 0 to t. So 1 by a minus b into integral 1 by b minus x, how much? Integral 1 by b minus x is how much?
Negative log of B minus X.
Negative logarithm of b minus x and divided by d by dx of b minus x. D by dx of b minus x is,
No, sir, I did with the.
you did that already. So
Yes.
logarithm of b minus x divided by, like integral 1 by x dx is ln x. Integral 1 by f of x dx is ln f of x divided by d by dx of f of x. That logarithm, my negative logarithm of b minus x will get here. My here minus of minus become plus, and you have the limit substitution. Limits 0 to x. Here also have the limit substitution. So we keep the minus sign only. Minus of negative logarithm of a minus x 0 to x is equals to k into t. So we'll get the expression 1 by a minus b into x, you substitute negative logarithm of b minus x, negative logarithm of b minus x, then you will get what? Negative logarithm of b minus x minus
Log B.
logarithm of log b. Minus into minus become plus or not?
Yes.
Yes, sir.
Yes or no? So same thing you do again.
Log A minus X plus log A is equals to KT.
Okay, so this is the complex equation you will get. Ultimately, you have the equation like this. So we can just add one more slide here. Just a second. Yes, ultimately what equation you will get? So k into, like 1 by a minus b, 1 by a minus b into log b by b minus x minus log a by a minus x you will get. log b by b minus x minus log a by a minus x, that is equals to k into t. So 1 by a minus b into logarithm of a by b minus x, b by b minus x whole divided by a minus x is equals to k into t. So 1 by a minus b into logarithm of b into a minus x by a into b minus x is equals to k into t. Everyone got this expression or not? So this is the expression which you have to do whenever the initial concentrations of a and b are different. 1 by a minus b into logarithm of b into a minus x by a into b minus x is equal to k into t. This is the integrated rate equation, integrated rate expression or rate equation when the initial concentrations of reactants are different in second order reaction. So you can imagine how complex it would be whenever the initial concentrations are different for third order reaction. For third order reaction, how complex it would be whenever the initial concentrations are different. Yes or no?
Yes, sir.
Yes.
So like that. So such type of calculations you should know at least for second order, if you know how to solve it. Generally, such questions will not be asked. It will be a difficult one because it takes time. Nothing difficult in solving, but takes time. But this is how you have to solve whenever they have given initial concentrations are different. But here initial concentrations are same, so you can just go with these expressions. Third order reaction, this is the rate equation, integrated equation, and T half 3 by 2k into initial concentration of A naught whole power 2. So same expressions you will get. Concentration of A at any time t is equals to 1 by concentration of A at time t is equal to 0 whole square plus 2 kg. If you try to plot a graph, 1 by concentration of A at time t whole square versus time, you get a straight line with a slope of 2k, which has an intercept of 1 by A naught square. T half is how much? T half 3 by 2k into concentration of A naught power 2. So if you try to plot a graph between T half and initial concentration of A naught whole square, what type of curve you will get? Again, a straight line passing through origin with the slope of 3 by 2k. T half versus 1 by concentration of A naught whole square, you get a straight line with a slope of 3 by 2k. The same, whatever we have done here, 3 by 2k A naught square, same graphs, they are repeated in the slides. Is that clear, students? Is everything clear? These are all the integrated rate equations for different orders, different types of orders of reactions.
Yes.
Yeah, try to solve this question. Given they are second order reaction graph, 1 by constant, second order reaction means we'll get what? 1 by concentration of A at any time t is equal to 1 by concentration of A at time t is equal to 0 plus k into t. What they are saying, y is equal to mx plus c, this is taken on the y-axis. Slope mx plus c, this is on the x-axis. Slope is how much? Slope is theta. Theta is equal to tan inverse of 0.5. Slope is equals to tan theta, that is equals to k. Theta is given as how much? Theta is equals to tan inverse of k, and theta is given as tan inverse of 0.5. So what is k? K is equals to 0.5. And what is OP? OP is nothing but 1 by concentration of A time t is equal to 0. OP is how much? 2. 2 is equal to 1 by concentration of A time t is equal to 0. So concentration of A time t is equal to 0 is 1 by 2, that is 0.5. What they are asking us to calculate? Calculate the find initial rate of reaction. Rate of the reaction at time t is equal to 0 is K into concentration of reactant at time t is equal to 0. What is that? What is the value of K? 0.5 into what is the concentration of A time t is equal to 0? 0.5. So what is K now?
0.25.
Sure? 0.25 or 0.025?
0.2.
But is it correct, or do we need to change some? Do we need to have some change? It is second order reaction. Rate at time t is equal to 0 is K into concentration of A at time t is equal to 0 whole square you have to write. Yes or no? If you write only K into concentration of A, that becomes first order, but it's second order reaction. So K into concentration of A whole part 2 at time t is equal to 0. So 0.5 into 0.5 whole square. 1 by 2 into 1 by 2 square. That is 1 by 2 into 1 by 4. That is 1 by 8. Similarly, calculate the rate after term 5 seconds. Rate of t is equal to 5 seconds is how much? K into concentration of A at time t is equal to 5 seconds whole square. What is the concentration of A at time t is equal to 5 seconds? 1 by concentration of A at time t is equal to 5 seconds is 1 by concentration of A at time t is equal to 0 plus K into time is 5 seconds. So what is the initial concentration? 1 by A naught is 2. 2 plus K is how much? 0.5. 1 by 2 into 5. Yes or no? Let us say 4 seconds. Time t is equal to 4 seconds. So the calculation becomes easy. T is equal to 4 seconds. K into 4. So you get half of 4 here. So how much is that?
4. 1 by
4.
8 is equal to
So 1 by 80 is equal to 4. What is 80? We need 80, right? So 0.5 is K.
0.25.
I can write 1 by 4 whole square. So 1 by 2 into 1 by 64. That is 1 by 128. So rate of reaction at time t is equal to 0 is 1 by 8. Rate of reaction at time t is equal to 5 seconds is 1 by 128. Is that clear or not?
Yes,
From
sir.
the graph
Yes.
also different types of questions can be asked. From the graph also they can ask us different types of questions. Try to solve this question. All of you try to solve this question. I'll be back within a minute. Yes, student, any answers for this question? In a second order reaction, both the reactants have equal initial concentration. The time taken for 60% completion of reaction is 3000 seconds. What will be the time taken for 20% completion of the reaction? Second order reaction, we have the equation. What was the equation for second order reaction? 1 by concentration of A at any time t is equals to 1 by concentration of A at time t is equals to 0 plus K into T. In the second order reaction, we have both, when both the reactants have equal concentration. If you read the question carefully, both the reactants have equal concentration, they have mentioned, yes or no? That means you are supposed to use this equation, not an issue. If both the reactants have unequal concentration, then whatever the equations we have derived earlier, like these equations we got, no? 1 by A minus B into logarithm of B into A minus X by A into B minus X is equal to KT. This we have to use. So in a second order reaction, both the reactants have equal initial concentration. The time taken for 60% completion of the reaction is 3000 seconds. What will be the time taken for 20% completion? For 20% completion, how much time it will be required? So can I solve this expression by using the same formula? Like 1 by 60% is done. 60% is done means concentration of A at time t is equal to 60% is, after 60% has been in, what is the concentration of A? 40% is remaining, right?
40%.
Yes, sir.
Yes, sir.
Right, so you can write 40 by 100 times that of initial concentration. So I can write the expression 1 by concentration of AT is 100
By 40 and
100 by 40 concentration of A naught is equals to 1 by
1
concentration
by
of A naught plus K into time is
3000.
3000 seconds. And what was the other equation? What will the time taken for 20% completion? If 20% is done, what is the time? 1000 by, like 20% is done means how much is
80 not
80?
1000 by 10.
So like
100 by 10.
100 by 80 A naught is equals to 1 by concentration of A time t is equal to 0 plus K into some time t. We have to find out this K value. From this expression, can I find the K value in terms of A naught?
Yes, sir.
So I can write a 100 by 40 A naught minus 1 by A naught. I'll write as 40 by 40 A naught. Multiply and divide with 40. No issues. K into 3000. So 60 by 40 A naught is equals to K into 3000. So 40, 22 times, 23 times. So K is how much? K is nothing but 3 1 times, 3000 times.
3000.
K is nothing but 1 by 2000 A
5
naught.
into 10 power minus 4.
1 by 2000 A naught or not? Check it out, all of you.
Yes, sir.
100 by 80 A naught. 1 by A naught I am taking to the other side. So I'll write it as 80 by 80 A naught is equals to K. K value is 1 by
1 by
2000 A naught
2000
into time t. So I'll write the equation as 20 by 80 A naught. 20 by 80 concentration of A naught is equals to 1 by 2000 A naught into T.
into T.
21 times, 24 times, A naught get cancels. So T is equals to 2000 by 4. 500 seconds.
500 seconds.
Yes, very good. T is equals to 2000 by 4. That will be nothing but 500 seconds. Try to solve this. Everyone got this or not?
Sir. Yes.
Yes, right. Simple questions only. You have to just solve it. You have to be patient and solve the calculate everything properly. The accompanying figure depict the change in concentration of a species as a function of time. For the reaction, A3 gives rise to 3A. The point of intersection of two curves represents. There was some diagram given. Time t is what? A3 is giving 3A. Try to think on this question, all of you. A3 is giving 3A. This was a reaction. At time t is equal to 0. Can I say A moles of A3 is there and 0 moles of A? That is 3A. At time t is equal to T, what I can say? Out of A moles, some X moles has been lost. If X moles of A3 lost, 3X moles of A should be produced. At time t is equal to T, we are writing the concentrations, number of moles. So concentration at the time t is equal to T is how much? Number of moles by volume. So A minus X by B into 3X by B, because they are in the same container. Now look at the condition. At time t, what happened? What you can say from time t? This is the A3 is the reactant, A is the product. Reactant concentration is decreasing, product concentration is increasing. So at a time t, can I say the concentration of reactant and concentration of product are same?
Yes, sir.
At a time t is equals to T, concentration of reactant is equals to concentration of product. What is the concentration of reactant? A minus X by V. Concentration of product is 3X by V. V gets cancels. So A is equals to what? A minus x is equal to
4x.
x, A is equals to 4x. From here, can I say x is equals to A by 4?
By 4. Yes, sir.
X is equal to A by 4. What is x? X is the amount of reactant converted to product.
A
How much
by
amount of A by 4? That means initial concentration A means initial number of moles. 1/4 of initial number of moles has been done. So what is the time? T 1 by 4 or not? T 1 by 4 is the time required for the 1/4 of the reaction to be done. So this time is nothing but T 1 by 4. X is equals to A by 4 means initially A moles are there. A by 4 moles have been converted to products. That means we can say the 1/4 of the reaction has been done. So T 1 by 4 is the right option. So these are the different orders. Then we will be going with the next theory known as collision theory of chemical reactions. Collision theory of chemical reactions. So how to understand this collision theory and all? So according to this collision theory, whatever the reaction we have, like we have A plus B gives rise to products. A is a reactant, B is also a reactant. A and B are colliding. A and B are colliding to form product. So collision theory says that the conversion of reactants to products is just because of collisions between the reactant molecules. The reactant molecules are colliding with each other to form products. Then you should ask a question yourself. Does every collision lead to product formation?
No, sir.
So first point is the reactant molecules are colliding to form products. Every collision is not leading to the product formation. Every collision is not leading to the product formation. Those collisions which are leading to the product formation, they are said to be effective collisions. Those collisions which are not forming the products, they are said to be ineffective collisions. Those collisions which are forming the products, they are effective. Those collisions which are not forming the products, they are said to be ineffective collisions. Now the question, for a collision to be effective, what are the conditions?
Perfect orientation and energy sufficient.
Very good, Faizan. Perfect orientation should be perfect and they should have some amount of energy. Why?
So that activation energy can be reached.
That's
Leading
what.
to product.
Why they should have activation energy? Why we should reach that activation energy?
Because they follow transition state which is unstable. That's all.
Actually, what is happening is whenever the colliding molecules, whenever the reactant molecules are colliding, it is the atoms which are closing in contact first or not. Like any molecule you consider any biomolecular system, whenever they are forming a activated stage, if you are saying that they are colliding and forming an activated stage, before that only what is actually happening means whenever they are coming and forming the activated stage, the two molecules will be having different atoms. The atoms will have electrons. The electron clouds are interacting. Yes or no? The repulsions are there between the electron clouds. Whenever the two species are colliding, whenever two molecules are completely colliding, the electron clouds are coming into contact or they are interacting. Because of electron clouds interacting, repulsion starts. Because of the collision should happen only when the repulsions are overcome, when the velocities are in such a way such that they have to overcome the repulsions. The velocities of the molecules or the energy of the molecule should be in such a way such that that has to overcome the electronic repulsions, and then only it will lead to the formation of some activated stage or activated complex. That activated complex formed can be again converting back to reactants or it can convert to products. If they have sufficient energy, they can reach the activated stage. If I have sufficient energy, I can climb the wall. But if I don't know the direction, I don't know where to go after climbing the wall. Yes or no? Like we have a big hill. I have the energy to climb the hill. I went to the top of the hill. That's fine. But after reaching the top of the hill, if I don't know how to come back or how to go or how to proceed to the other way, then even though I have energy, it is of no use. Same thing. The reactant molecules have the energy. They collided. They went to the activated stage. But if they don't know the orientation, if they do not collide in a proper way, they will again disperse in different directions. Let us say two billiard balls colliding like this. They'll collide and disperse. Whenever the orientation means what? Whatever the electron densities we have in the molecules, they should properly overlap, because a new bond has to be formed. A new orientation has to be developed between the reactant molecules. Right? So reactant molecule should possess minimum amount of energy. The reactant molecules should possess minimum amount of energy to participate in a chemical reaction. That is, they should have some threshold energy. And the minimum extra energy required by the reactant molecules to form products is the activation energy. So there was a difference between activation energy and threshold energy. So can I say threshold energy, E threshold is equals to E activation plus energy of reactant molecules?
Yes.
That means the activation energy plus the kinetic energy of the reactant molecules, when you try to add these two, then only you will get the threshold energy. So this theory was given by Max Strauss and William Lewis. This theory is based on the kinetic theory of gases. What kinetic theory of gases says? The reactant molecules are colliding with each other because of collisions. The reactant molecules are moving with very high velocities in different directions. They collide with each other as well as with the walls of container. Because of that, they are exerting pressure on the wall of the container. In this theory, reactant molecules are assumed to be hard spheres, and for a reaction to occur, there must be collisions in between reactant molecules. For a reaction to occur, there must be collisions in between reactant molecules. Total number of collisions per second in unit volume is called as collision frequency Z. Total number of collisions per second in unit volume. In 1 unit volume, in 1 second, how many number of collisions are happening? That is called as collision frequency. Collision frequency will be a very high number, something approximately 10 power 25 to 10 power 28, even greater than the Avogadro number. Generally, the value of collision frequency is very high for the gaseous reactions. 10 power 25 to 10 power 28 collisions are going to happen in 1 second in 1 unit volume. You can imagine the total volume. You can imagine the great time. In 1 second itself, these many collisions are happening. Out of these collisions, all the collisions are not effective, only some are effective. All collisions between reactant molecules do not lead to formation of products. Only a small fraction of these collisions are capable to convert reactant into product. Those are said to be effective collisions. And those molecules which are converting into product are said to be active molecules. The collisions which are leading to product formation are effective collisions. The molecules which are converting into products, they are said to be active molecules. The collisions which are not leading to product formation, they are ineffective, and those molecules are inactive molecules. Those collisions in which reactants are converted into products are called effective collisions. The molecules which are converting into products are said to be active molecules. This is an effective collision happening. Those collisions in which reactants are not converting into products are said to be ineffective collisions, and the molecules are known as inactive molecules. This is effective collision, and this was your respective ineffective collision. Ineffective collision, you can see the reactants are just like they collided and moved back as reactant only, no chemical change. Is that point clear or not?
Sir.
Yes.
Yes, right? Very good. For effective collision, following two conditions must be satisfied simultaneously. What are those? Reactant molecules must possess a minimum amount of energy. Why? To overcome the electronic repulsions. Proper orientation of collision. The orientation should also be good, so that electron densities can overlap to form new bonds. Because new bond has to be formed means the overlapping of atomic orbitals itself is leading to bond formation. Bond is not the new chemical bond, a new covalent bond is formed only when the overlapping of atomic orbitals happen. The atomic orbitals has to overlap means they should be properly oriented. If they are not oriented, there is no overlapping. There is no overlapping means there is no bond formation. So reacting particles that must possess a minimum amount of energy. Proper orientation of collision should be there. Reacting particle must possess a minimum amount of energy. That minimum amount of energy is said to be threshold energy. What is threshold energy? The minimum energy which must be possessed by reacting molecules for a chemical reaction to occur. For a chemical reaction to occur, what was the minimum amount of energy possessed by reactant molecules? That is said to be threshold energy. What is activation energy? The minimum extra energy possessed by reactant molecules to cross the activated stage. Activation energy is the minimum extra amount of energy required by reactant molecules for converting into products. If you try to understand, let us take an exothermic reaction. Somewhere we have reactants here and somewhere we have products here. The reactants are going to be converting into products. Reactants are going to be converting into products. From the x-axis to the activated stage, whatever the energy we have, this is nothing but your E threshold. From the reactants to the activated stage, whatever the energy we have, that is called as activation energy. Of course, for the forward reaction. Between the reactants and products, whatever the energy we have, that is nothing but delta H. Delta H is the enthalpy change between reactants and products. This is the energy. This is the course of reaction. Everyone got this or not? This is nothing but activation energy of forward reaction or backward reaction.
Forward reaction.
Forward.
Backward reaction. For backward reaction from the product to the activated stage. This is nothing but activation energy of backward. This is nothing but activation energy of forward. A of F. Activation energy of forward, activation energy of backward, threshold energy, delta H, energy you have taken on the y-axis. These are all the conditions. Right? So this is how the reactant molecules are there. The reactant molecules are trying to form the products. Reactant molecules cannot cross the energy barrier, they cannot be forming products. If they can cross the energy barrier, they can form the products. And this theory, this whole collision theory is only applicable for only bimolecular systems. And there are a lot of complex organic reactions where the number of atoms in the molecule itself is very high. In such cases, this theory is not applicable. You cannot say every reaction in nature is just because of collision. That is wrong. Not every reaction in the nature is actually happening because of collisions. And here in the collision theory, we are assuming the molecules as hard spheres. But we know molecule have a different structure, different shape. Yes or no? All those are neglected. This is only for smaller bimolecular reactions where the reactant molecules were all assumed as a hard spheres. Right? So the energy profile diagrams we'll discuss for the exothermic reaction and endothermic reaction in the next class. So that discussion we'll do, and then we'll look at the different types of factors on which the rate of reaction is going to be depending upon, and solve some questions, and then proceed to the next chapter named surface chemistry. Fine, students. Thank you all, everyone. Bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.